Hello everyone, this is Premraj Jayaprakash. Welcome to AI All Around. Everyone in tech is asking the same question right now. Will AI replace developers, software engineers and architects, or will it make us more effective? In my last video, we talked about 4 strategic capabilities that actually becomes more valuable in an AI augmented environment. After that, I got a lot of message from many of you asking the very simple practical question. What technical skills do I need to know and which AI tools should I learn? Those are all important questions, but they are not the first question you should ask. Before we talk about specific skills, tools or tech stacks, you need the right mental model, the mindset that guides you how you think about AI, your work and your role in the team. If we get this wrong, you will chase every new tool and still feel stuck. In this video, I want to walk you through that mental model or the mindset that guides how you choose your tech stacks in the AI world. Every week there is a new headline. AI writes code, AI fixes bugs, AI runs infrastructure. So naturally people start asking, will there still be a place for me in this industry? But here is what I am seeing across engineering teams and technology organizations. The engineer who are thriving in 2026 are not the one who is avoiding the AI. They are the ones learning how to use AI to amplify their impact. In this video, I will show you what actually changed in the industry, the 5 skills that makes engineers AI proof, what should stop doing immediately, and 12 months roadmap to amplify your tech career using AI. Because the real competition today is no longer you versus AI. It's more you with AI versus someone else with AI. Let me start with the simple story that captures this shift. Last year, I spoke with a cloud infrastructure engineer who manages the Kubernetes platform. His team lived in incident land. Every time something went wrong in production, they had to dig through logs, check recent deployments, correlate metrics with different tools, write an incident summary, and draft the root cause analysis. 2 hours disappear into multiple dashboards and log files. If you have done this, you know how it feels. You have to spend multiple hours digging dashboards and log files. He started asking a simple question. What if AI could handle the boring 70% of this process? So he built a small AI assistant. When an alert fired, the system would pull relevant logs and metrics, summarize the likely cause, highlight the suspicious commits, and generates the first draft of the incident report. Nothing magical. He still review everything, he still own the decision. But suddenly what used to take 2 hours started taking just 20 minutes. Here is the important part. The biggest change wasn't the time saved. The biggest change was the mindset. He started thinking of how can I use AI to handle the boring 70% of the process. Leadership started asking him, could we use the same approach for change management, for cost reports, for on-call handovers? Within few months, he became the internal AI platform lead. Not because he became the best programmer in the team, but because he understood how AI fits into real systems. He stopped thinking of AI as a threat to his job. He started treating it as a force multiplier for his judgment. This is the opportunity most engineers and architects are walking past right now. So before we go further, I want you to ask yourself one simple question. In your current job, where are you still doing work that an agent could at least help with? 2 years ago, AI felt like a side experiment. You opened a chat box in a browser, type a question, and hope the answer was useful. Today, AI has quietly moved from separate tool to embedded coworker. If you are a developer, you have seen this. Tools like GitHub Copilot sit inside your editors like VS Code and JetBrains, generate the entire function, unit test cases, even refactoring in seconds. In some teams, large percentage of new code now generated as a AI suggestion. Then the developer modifies and owns. If you are working in operations or infrastructure, you are seeing the same pattern under a different name, AI Ops. Monitoring platforms like Datadog and Dynatrace use machine learning to spot anomalies, correlate metrics, and points you to the most likely root cause before you even open a dashboard. CI/CD pipelines are changing too. Automation systems like GitHub Actions are increasingly wired with AI agents that can analyze failed builds, summarize error logs, and sometimes even propose a patch or open a pull request for you to review. So the daily reality is shifting from I write and run everything in a manual way to I design systems where AI does part of my work and I am accountable for the outcome. So here is a key insight I want you to remember from this video. AI is compressing the execution layer of engineering, the part where we type, click and repeat. At the same time, it is expanding the design, orchestration and architecture layers, the part where we decide what should happen in what sequence under what guardrails and why. The AI shift makes you scared if you keep your identity tied only to the execution layer, where I am the person who writes all the code, who clicks all the buttons. If you start to see yourself as a person who designs how humans and AI work together, the shift becomes promotion opportunity. So what does this mean for your career? The old tech career ladder was straightforward. Junior engineers wrote code, mid-level engineers wrote more complex systems, senior engineers and architects designed the big picture and review what others built. The entire ladder assumed that writing code yourself was the main unit of value. That assumption is breaking now. Let me show you what the new ladder looks like. Think of its three layers. Execution layer, writing code, running scripts, performing repetitive tasks. This is where AI is moving fast. Orchestration layer, designing workflows that combine AI capabilities with human judgment, defining what's get automated, where humans approve and how systems stay safe. The strategy layer, defining architecture, governance, platform standards, and long-term direction. Here is a critical insight. AI is compressing the execution layer, but it's automatically or drastically expanding the orchestration layer, which leads to the single most important career principle in 2026. Prompting is the new typing. Everyone will know how to do it. But orchestration is where you really need to be, where designing how works get broken down, how AI is used, how humans review and decide, that's the new senior skill. Now, this looks slightly different depending on whether you are a developer or working in a cloud or infrastructure. Let's see on both sides. On the development side, juniors will be expected to ship features with AI in the loop by default. Mid-level will supervise AI generated code across multiple services, integrating it safely and owning quality. Seniors will design human plus AI workflows into the entire SDLC, how it touches requirements, code, test, security, deployment and monitoring. Let's say you are on the cloud and infrastructure side. For infrastructure folks, the ladder looks similar but with different tools. At the implementation layer, you are using AI for things like Terraform generation, config validation, and runbooks drafting. At the mid-level, you are integrating AI into your platform AI Ops for anomaly detection, predictive scaling, automated rollback workflows. At the top, you are designing AI native infrastructure, including GPU clusters, model servicing platform, policy-driven automation, and multi-cloud strategies where AI decides resource placements based on cost, latency, and compliance. So the infrastructure role is moving from I respond to alerts and fix things to I define policies and guardrails where autonomous system operates under. If you see yourself only as a person who writes the code or the person who fixes the server, this ladder feels scary. But if you see yourself as a person who designs systems where human and AI collaborate, this ladder feels exciting. In comments, feel free to mention where do you currently sit on this ladder. Are you focused mostly on execution, or are you started to design how your team uses AI? So by seeing this new ladder, we are going back to the same question. So if a significant portion of execution work become automatable, what skills become more valuable? I am going to walk you through 5 skill sets. They are not vague soft skills, they are technical and strategic capabilities that multiply your impact in an AI augmented environment. Skill number 1, agentic workflow design. This is the ability to look at a problem and break it down into steps that AI and tools can actually execute. Instead of thinking, write me a code, you think in terms of clarify requirements, generate code, generate test, run checks, summarize results, ask for human approval. Let me give you 2 examples. For a developer, imagine a bug fix workflow. Today, many teams still do this manually. Triage the ticket, understand the logs, locate the code, write the fix, write test cases, create a PR, write the summary. But if you are an agentic workflow designer, you should ask which of these steps can AI can do reliably, where do humans need to step in. Then you build that as a repeatable pipeline. If you are a cloud engineer, you design a SRE agent that sees a CPU spike in Kubernetes, check logs and correlates with the recent deployment, rolls back automatically, updates the incident ticket, posts a RCA draft to Slack, all under strict policies you define. If you can design those pipelines, you are no longer just using AI. You are the person who decides how the entire team uses AI. Again, I want you to think one workflow you do at least weekly. Could you sketch it as a series of AI plus human steps right now? Skill number 2 is AI ready system architecture. Most existing systems were not designed for AI models to call internal APIs, read internal data, generate code or config that hit production. An AI aware architect, you should ask questions like, how do we expose the right data safely? What APIs and abstraction do we give it to our agents? Where do we put guardrails so they cannot break things? As a developer in practice, that might look like designing an internal AI gateway or rack service so team doesn't hit the external LLM directly. You create a control interface, not open access. For a cloud or infrastructure engineer, you might be designing an AI gateway that fronts all model calls, applies organizational policies, handles auth, rate limiting and logging, routes between the providers based on cost and latency. Teams never call the raw model, they call your platform. If you can speak both architecture and AI, you become very hard to replace because you are designing the environment everyone else has to work inside. Skill number 3, governance, risk and cost thinking. Getting a cool demo is easy. The hard part is making something that a security team, compliance team and CFO are comfortable running in production. That means thinking about logging and monitoring, validate frameworks to catch bad outputs, safety checks and fallbacks, cost controls. Here is a concrete example. If you are an engineer who can say, here is our fallback when the model hallucinates, here is how we monitor for the bad responses, here is how we cap the cost per request, and here is how we prove this is a compliant with our data policies. If you do so, you are instantly more valuable inside an enterprise than someone who just build clever prompt chains. A lot of organizations in 2026 don't have enough people to understand both AI capabilities and governance concerns. The gap is a huge opportunity. This is where most AI projects die. The demo works, everyone excited, but it never gets blessed for production because no one designed governance from the start. If you own this layer, you become indispensable. Skill number 4, combining domain experience with AI. A generic AI engineer is becoming less interesting than AI with fintech engineer, AI with healthcare engineer, AI with cloud infrastructure architect. Why? Because many of the hardest problems are not in the model. They are in understanding the real world constraints of a specific domain, especially regulation, edge cases, what good actually looks like in context. Let me give you some 2026 market data. A January 2026 report on AI software engineer jobs calls 2026 the breakout year for AI literate engineers. They point out most of the teams don't have enough people who can write software and understand how the models behave under real traffic with latency, cost and reliability constraints. Those hybrid engineers are commanding a premium salary right now. For cloud infrastructure, the same pattern shows up. Multiple independent reports for 2026 calls that hybrid skill sets get paid more and gets pulled into most interesting projects. Skill 5 is learning speed and tool fluency. The one guarantee we have is that tools are going to keep changing. Framework, SDK, best practices, they are all on a 6 to 12 month cycle right now. If your strategy is, I will learn one tool and hope it stays dominant, you are going to constantly behind. What companies are really looking for? Can you pick up a new AI framework in a week? Can you read the docs, ship a proof of concept, and then decide it's worth standardizing? Can you adapt the mental model as the ecosystem shift? Here is what hiring manager actually posting for 2026 cloud roles. They want Kubernetes, Terraform, GitOps, and then AI integration, AI ops, and automation first platform engineering layered on top. If you show that you can learn fast and you are comfortable with change, you are sending a very strong signal that you are built for this AI era. Your track record of successfully navigating disruption from on-prem to cloud, from the VM to containers is the one of your most valuable assets. Remember that. So far, we have seen the top 5 skills what we need. Now let me flip this and talk about what you have to stop doing, because it's just as important to know what not to invest your time in. Trap number 1, becoming a prompt monkey. If your entire job becomes writing prompts or a simple scripts on demand without owning any systems or outcome, that's exactly the kind of work AI itself is getting better at. Don't compete at the layer AI is automating. Trap number 2, treating AI like a toy or an interview cheat. If the only time you use AI to help you with sample code, but you are not using it in your actual day-to-day work, you are missing the point. Companies now expect at least basic AI literacy in software and infrastructure roles. Trap number 3, profile clutter. Listing 20 different AI tools on your CV doesn't impress anyone in 2026. What's matter is 2 to 3 concrete examples where you used AI to ship something that changed a metric. For an example, reduce cycle time, cut incidents, speed up onboarding, improve customer response. Any one of these metric supposed to be a good example of how you can build your CV. So if you think about your own career, ask yourself, am I just stacking tools and prompts, or am I taking responsibility for systems, workflow and the results? So at the end, the question should be, are we building skills that makes us more valuable, or are we building skills that AI will automate next. I hope you understand. Alright, let's wrap this up here. In this video, you focused on the mental model you need so you don't compete with AI at the task level, but design how AI works inside your systems and your career. In the next video, we will discuss the 12-month roadmap to reach tenfold impact, where I will walk you through exact skills, habits and activities to stack over the next year so you come out of this AI wave much stronger, not replaceable. Thanks so much for watching. I am Premraj Jayaprakash and this is AI All Around.